switchgear contains high voltage. Failure to observe these precautions will result in serious personal injury or death. Some of these precautions may differ from company operating procedures and rules. Where a discrepancy exists, users should follow their company's operating procedures and rules. This video is intended to be used in conjunction with the written instruction sheet included with your product. In this instructional video, we will perform the opening, closing, and internal grounding of the Vista underground distribution switchgear. S&C offers a wide variety of Vista models and configurations. The operating procedure is similar for all models and configurations. Before operating, always check the SF6 gas gauge, that the blades are in the correct position, and that any fault interrupter has not experienced a trip operation. To view the SF6 gas pressure gauge, lift the viewing window cover of Way 1 of the Vista switchgear. Ensure that the pressure gauge is in the green zone. If the pressure gauge is in the green and yellow stripe zone, the switchgear can be operated, but the unit must be evaluated to determine whether it needs to be refilled with SF6 gas. Contact S&C for more information. If the pressure gauge is in the orange zone, the gauge itself is not working properly. Contact S&C for more information. Do not operate this switchgear if the SF6 gas pressure gauge is in the red zone. Failure to follow this precaution can result in a flashover and equipment damage. To check the blade position, open the viewing window cover of the way you will operate and confirm the position of the load interrupter switch or fault interrupter by visually observing the position of the blades. For all models except manual 15 kV, 12.5 kA models, here are the blades in the closed position. The open position and the grounded position. For 15 kV, 12.5 kA models, here are the blades in the closed position. The open position and the grounded position. Also, inspect the current carrying components inside the tank for any signs of abnormalities, but specifically for disconnect blade alignment, contact finger position, and dislodged hardware. Do not operate the energized load interrupter switch or fault interrupter with dislodged hardware or obvious signs of arcing or blade misalignment. Equipment damage and personal injury may result. The operation selector prevents operation from the closed position to ground and vice versa. If the operation selector is blocking the handle, rotate the selector out of the way. To operate the switch, insert the manual operating handle in the operating mechanism. To operate from the closed to the open position, rotate the operating handle counterclockwise all the way to the stop, as shown on the label. To operate from the open to the grounded position, rotate the selector out of the way and rotate the operating handle counterclockwise to a stop in the grounded position. To operate from the grounded to the open position, rotate the selector out of the way and rotate the operating handle clockwise to a stop in the open position. To operate from the open to the closed position, rotate the selector out of the way and rotate the operating handle clockwise to a stop in the closed position. On switches with a 3-pole fault interrupter, the handle cannot be removed until the mechanism is fully charged. Always make sure that the cables connected to the load interrupter switch or fault interrupter are de-energized before grounding the switchgear. Failure to follow this precaution can result in a flashover and equipment damage. The trip indication will be different depending on the model of switchgear. For most models, a trip flag will be present in the viewing window after a trip operation. For a 3-pole fault interrupter, there will be a single flag. A single-pole fault interrupter will have a trip flag for each phase. For manual 15 kV, 12.5 kA models, there is no trip flag. The blades will be in the open position while the operating disc will still indicate it is in the closed position. As always, go through the pre-operation checks. When tripped, the fault interrupter will need to be operated to the open position to reset the operating mechanism. Do this by rotating the handle all the way to the stop position. The fault interrupter can then be operated to the grounded or closed position. Your operating procedures may require locking the operating mechanism in various positions. To prevent operating a load interrupter switch or fault interrupter to ground, you can lock out the grounded position. To lock a load interrupter or fault interrupter out of the grounded position, insert a padlock through the operation selector and the right side hole of the locking collar. To lock a load interrupter or fault interrupter out of a closed position, attach the padlock through the operation selector and the left side hole of the locking collar. You can also lock a load interrupter or fault interrupter into the open, closed, or grounded positions by inserting a padlock through the operating disc and the center hold in the locking collar. The optional voltage indicator is used to check for voltage on the phases of the load interrupter switch or fault interrupter. Before using the voltage indicator, always test to make sure it is operating properly. Clean the surface of the photocell and the test button if necessary. If the test button is dirty, the voltage indicator will be in the test mode and may give a false indication that all three phases are energized. The test mode is indicated by a dot in the test window. Cover the test button with a gloved finger. If there isn't enough sun to power the photocell, shine a non-LED flashlight 4 inches above the photocell. If a dot appears in the test window and a flashing lightning bolt in each of the 3 phase indicators, the voltage indicator is operating properly. If the dot or any of the flashing lightning bolts do not appear, make sure that the test button is completely covered. Also make sure that there is adequate light, either from the sun or a flashlight. If the dot or any of the flashing lightning bolts still do not appear, the voltage indicator may be damaged. Test for voltage using an alternate method. After testing the voltage indicator, you can check the indicators to determine if there is voltage at the associated bushings. A flashing lightning bolt in the phase indicator means that voltage is present at the bushing. A blank means that there is no voltage at the bushing. Next, we will perform low voltage phasing using the optional voltage indication with phasing. First, clean the surface and phasing pins if necessary. Using a high impedance voltmeter, verify that voltage is present and determine the phase to ground voltage for each phase of the 2 ways to be phased as follows. Set the voltmeter to volts AC. Ground the voltmeter by connecting one of the test probes to the tank. Place the other test probe on the phasing pins in turn of the 2 ways to be phased and measure the phase to ground voltage. If the voltage measured at any of the phasing pins is 0, the phases are not energized and phasing cannot be performed. If the voltages measured are not equal, the voltmeter may not be operating properly. Phasing should be performed using an alternate method. Determine the phase-to-phase relationships of the 2 ways to be phased as follows. Remove the test probe of the voltmeter from the switchgear tank. Place one of the test probes on phasing pin 1 of the first way and place the other probe on phasing pin 1 of the second way. Measure the phase-to-phase voltage. When comparing the same phase of 2 ways, the voltage should be 0 or close to 0, indicating that the cables are in phase. Keep the test probe on phasing pin 1 of the first way. Move the other test probe to phasing pin 2 of the second way. Measure the phase-to-phase voltage. When comparing different phases of 2 ways, the voltage should be 1.7 to 2 times the phase to ground voltage. Keep the test probe on phasing pin 1 of the first way and move the other test probe to phasing pin 3 of the second way. Measure the phase-to-phase voltage. Again, when comparing different phases of 2 ways, the voltage should be 1.7 to 2 times the phase to ground voltage. If all the phase-to-phase relationships are correct, the cables are in phase and properly installed. To return the switchgear to service, make sure the load interrupter switch and fault interrupter grounding means are removed. Make certain the load interrupter switches and fault interrupters are in the correct open or closed positions. If a pad-mounted enclosure is furnished, make sure the termination compartment is closed and padlocked before energizing the circuit and operating any switching devices. Padlock the switchgear before leaving the site, even momentarily. Observe this procedure even in those cases where the gear is accessible only to qualified persons. We hope you found this video informative. If you have any questions, please visit our website at sandc.com.